Sustainable Design. Part 1. Introduction to Sustainable Design. The need for sustainability in design. The world is at a crossroads. With the effects of climate change, resource depletion, and environmental degradation becoming increasingly evident, the design of products, buildings, and systems must evolve to address these challenges. The traditional linear economy, characterized by a take-make-dispose mentality, has resulted in overconsumption of natural resources, excessive waste, and profound ecological impacts. As a response, sustainable design offers an alternative that minimizes harm to the environment, maximizes resource efficiency, and ultimately promotes a healthier planet. Sustainable design is not just a trend or a passing phase. It is a critical response to the urgent need for a future that balances human needs with ecological integrity. Whether through reducing energy consumption, using renewable materials, or ensuring waste is minimized or repurposed, sustainable design practices aim to create long-term solutions to the environmental issues we face. Historical perspective on sustainable design. While the concept of sustainability in design is often associated with modern environmental movements, its roots extend back far earlier. Indigenous cultures across the globe have practiced sustainable design for millennia, using materials that were locally sourced and developed techniques that respected the environment's natural limits. The 20th century, however, saw the rise of industrialization and mass production, which led to a significant increase in environmental degradation. In the 1960s and 1970s, the rise of environmental consciousness, spurred by works like Rachel Carson's Silent Spring, 1962, and The First Earth Day, 1970, began to highlight the environmental costs of unregulated development and consumerism. This led to the birth of eco-friendly movements and the concept of sustainable development. In the realm of architecture and design, pioneers like Frank Lloyd Wright, with his philosophy of organic architecture, and later, the advent of green building movements in the 1980s, marked the beginning of a concerted effort to integrate sustainability into design practices. However, it wasn't until the early 21st century, with growing concerns about climate change and resource scarcity, that sustainable design became a mainstream consideration in various industries. This shift was also supported by the increasing availability of sustainable materials, energy-efficient technologies, and a deeper understanding of life cycle assessments, LCA, that measure a product's environmental impact over its entire lifespan. Defining sustainable design. At its core, sustainable design refers to a design philosophy that seeks to minimize negative impacts on the environment through thoughtful, efficient use of resources. Sustainable design involves minimizing waste, reducing, reusing, and recycling materials to avoid landfill accumulation. Conserving energy, prioritizing energy-efficient technologies and systems while minimizing reliance on fossil fuels. Utilizing renewable resources, selecting materials and energy sources that regenerate over time, e.g., solar power, wind, sustainable wood. Supporting social equity, ensuring that design decisions are inclusive, socially responsible, and address the needs of all stakeholders. Fostering resilience, designing systems, buildings, and products that can withstand environmental challenges and adapt to changing conditions. Sustainable design spans multiple sectors, from architecture and urban planning to product design, interior design, and even fashion. Every design decision can either contribute to environmental harm or play a part in environmental restoration and regeneration. In essence, sustainable design isn't just about green solutions, it's about creating a world where design serves not only the present generation's needs, but also safeguards the resources and environment for future generations. By rethinking how products, buildings, and infrastructure are conceived and produced, sustainable design practices can lead to more harmonious and resilient systems. The growing importance of sustainable design. The importance of sustainable design has never been more apparent. The evidence for the environmental crises facing the planet, such as climate change, biodiversity loss, and pollution is increasingly undeniable. These issues are linked to industrial practices that prioritize short-term gain over long-term health, both for the planet and humanity. But the good news is that the principles of sustainable design offer concrete solutions that can help mitigate these problems. Governments, corporations, and individuals alike are beginning to recognize the vital role of design in this transformation. International agreements like the Paris Agreement, aiming to limit global warming to below 2 degrees Celsius, underscore the importance of reducing carbon emissions. Meanwhile, forward-thinking companies are recognizing that sustainability can be a driver of innovation and growth, with consumer demand for eco-friendly products on the rise. In this new paradigm, sustainable design is viewed not as an additional cost or burden, but as a strategic opportunity. Through sustainable practices, businesses can improve efficiency, reduce costs, attract environmentally conscious consumers, and contribute to a positive environmental legacy. Moving towards a sustainable future. As we continue to confront the complex challenges of the 21st century, sustainable design offers a hopeful vision of a future where the built environment and the natural world coexist harmoniously. This vision is supported by ongoing advancements in technology, materials science, and energy systems, all of which enable designers to create innovative solutions that support sustainability. However, the shift towards sustainable design will not be without its challenges. The transition to more sustainable systems requires rethinking how we value resources, how we structure industries, and how we design for long-term outcomes instead of short-term profits. It also requires collaboration among designers, consumers, policymakers, and scientists to ensure that sustainable practices are accessible, equitable, and effective. The task of sustainable design is daunting, but it is also incredibly rewarding. Designers, engineers, architects, and innovators have the opportunity to shape a future where design serves both people and the planet. By embracing sustainable principles, we can create a world that is more resilient, resource efficient, and in tune with the natural systems that sustain life on Earth. Conclusion: the role of designers in shaping a sustainable world. As we begin this journey into the world of sustainable design, it is important to recognize the immense power that design holds in shaping our future. Every decision a designer makes, from selecting materials to determining energy systems, can have a lasting impact on the environment, economy, and society. Sustainable design is not just about using eco-friendly materials or reducing waste. It is about transforming our relationship with the planet and finding new ways to design for the long-term health and well-being of future generations. In the following parts, we will explore the principles, strategies, and tools that designers can use to integrate sustainability into their practices and contribute to a greener, more sustainable future. Part 2: Principles of Sustainable Design. The 3 rupees: reduce, reuse, recycle. One of the foundational principles of sustainable design lies in the 3 rupees: reduce, reuse, recycle. These concepts are essential to minimizing waste, conserving resources, and lowering environmental impact. Let's break them down in the context of sustainable design. Reduce. The principle of reduction emphasizes minimizing the consumption of resources. Sustainable design encourages designers to use fewer materials, less energy, and fewer water resources, ultimately reducing the overall environmental footprint. This can be achieved in a variety of ways. Material efficiency. Selecting materials that serve multiple purposes or that can be easily sourced and have low environmental costs. Energy consumption. Using energy-efficient designs, such as passive heating and cooling systems in buildings or low-energy production processes for products. Streamlining production. Reducing waste by designing products with minimal waste during manufacturing, such as creating products that require less material in the production phase. Example: a company designing packaging might aim to reduce the amount of plastic used in packaging by designing smaller, more compact packages that require less material. Reuse. Reusing products or materials is about giving items a second life before they are discarded. Reusing can help reduce the demand for new raw materials and lower energy costs associated with manufacturing. Sustainable design encourages the repurposing of materials and components wherever possible, extending the life cycle of both products and materials. Upcycling, transforming old products into new items of higher value, such as turning a discarded plastic bottle into a new useful product. Modular design, products that are designed to be disassembled and reused in different configurations or as parts for new products. Example: designing modular furniture that can be reconfigured as the needs of the user change, or reusing timber from an old building in a new construction project. Recycling involves processing used materials to make new products, conserving both natural resources and energy. Recyclable materials, such as metals, glass, paper, and plastics, are often given a new life through recycling, reducing the need for virgin resources and reducing the amount of waste that ends up in landfills. Recyclable materials, ensuring that products are made from materials that can be easily recycled after their use. Design for disassembly, creating products in a way that makes them easy to take apart, so their individual components can be separated and sent to the appropriate recycling streams. Example: electronic devices designed with materials that are easy to disassemble, allowing users to recycle components like batteries, circuit boards, and plastics. Life cycle thinking. Sustainable design goes beyond focusing on the immediate impact of a product and looks at its entire life cycle. Life cycle thinking involves considering the environmental and social impacts of a product or system from its conception to its disposal. This approach is grounded in the idea that every stage of a product's life, from raw material extraction to end-of-life disposal, has an environmental footprint. Cradle to grave. This traditional approach examines the environmental impacts associated with the entire life cycle of a product, from raw material extraction, cradle, through production, use, and finally disposal, grave. The goal is to minimize negative environmental impacts at every stage. Cradle to cradle. This newer concept, introduced by William McDonough and Michael Brongart, emphasizes the potential for products to be part of a closed-loop system. Instead of reaching a grave at the end of life, products designed for the cradle-to-cradle model can be disassembled and reused indefinitely, with materials circulating back into the production cycle, either as biological nutrients or technical nutrients, materials that can be used again in manufacturing processes. Key steps in life cycle thinking. Material sourcing. Choosing materials that are abundant, renewable, or have minimal environmental impact during extraction. Manufacturing. Optimizing processes to reduce energy consumption, minimize waste, and ensure that byproducts are either reused or recycled. Use phase. Designing for durability and longevity, which reduces the frequency of replacements and the overall environmental impact. End of life. Considering the disposal phase from the beginning of the design process, ensuring that materials can be recycled, composted, or safely returned to the environment. Example: a company designing a plastic bottle might look at the entire life cycle of the bottle, from how the plastic is made, how the bottle is used, and how it will be disposed of. A cradle-to-cradle approach might involve using biodegradable materials or designing the bottle to be fully recyclable, ensuring it doesn't contribute to long-term waste in landfills. Efficiency and performance. Efficiency is at the heart of sustainable design. By designing systems, products, and buildings that use fewer resources, such as energy, water, and raw materials, we can reduce environmental impacts and lower costs over time. Energy efficiency. In sustainable design, energy efficiency refers to reducing the amount of energy required to perform a task or function. This can involve using materials that provide better insulation, integrating renewable energy sources like solar panels or wind turbines, and using energy-efficient appliances and lighting systems. Example: a building with passive design elements, such as strategic window placement for natural lighting or a product that uses minimal power in standby mode. Water efficiency. Sustainable design also focuses on water conservation. Using less water in manufacturing, reducing water waste in products and buildings, and implementing water-efficient technologies are key components. Example: a showerhead that uses less water without sacrificing performance, or a building designed to capture rainwater for use in landscaping. Material efficiency. Material efficiency means designing products and systems that maximize the utility of raw materials, reducing waste, and minimizing the environmental impact of resource extraction. Example: designing products that use less material without compromising on strength or quality, such as lightweight, high-performance materials used in construction. Performance. A sustainable design should also meet the performance standards required by the user while still conserving resources. For instance, a product that is both durable and energy efficient ensures that resources are used wisely over its lifespan. Example: a sustainably designed car that uses less fuel but also provides the same level of safety and comfort as traditional models. The role of technology in sustainability. Technology plays a pivotal role in sustainable design, enabling designers to create more efficient, less harmful systems and products. From advanced materials science to digital tools for simulating environmental impacts, technology helps reduce resource use and streamline the design process. Smart technologies. Smart devices and systems that automatically adjust energy use, such as smart thermostats or automated lighting systems, can significantly reduce the energy consumption of homes and buildings. Example: a smart home system that adjusts heating and cooling based on occupancy and time of day, optimizing energy use. Green building technologies. In architecture, sustainable design increasingly incorporates green technologies such as solar panels, wind turbines, and green roofs. These systems allow buildings to generate their own energy, reducing their reliance on external energy sources and minimizing their environmental impact. 3D printing. 3D printing allows designers to create products using only the material they need, significantly reducing waste. It also offers the potential to use sustainable materials in the manufacturing process. Life cycle assessment tools. Modern software tools allow designers to conduct life cycle assessments, LCAs, on their products, helping them understand the environmental impacts of materials and manufacturing processes over the entire product life cycle. Conclusion: integrating the principles into design. The principles of sustainable design, reducing, reusing, recycling, life cycle thinking, efficiency, and leveraging technology, are all interconnected. By applying these principles at every stage of the design process, designers can create products, buildings, and systems that have a lower environmental impact and are more resource efficient. Sustainable design requires a holistic approach that considers not just the immediate benefits of a product or system, but its long-term environmental, social, and economic impacts. By embracing these principles, we can work toward a more sustainable future, one where design contributes to the well-being of people and the planet. Part 3. Environmental impact and ecological considerations. The impact of climate change on design. Climate change is one of the most pressing challenges of our time, and its effects are being felt across the globe. Rising temperatures, extreme weather events, and changing ecosystems are all consequences of human-induced climate change. As the world continues to grapple with these changes, sustainable design must play a pivotal role in mitigating the environmental impacts of the built environment. Designing for climate resilience. Sustainable design has the potential to help buildings, products, and systems adapt to the effects of climate change. This involves designing for resilience, ensuring that structures can withstand extreme weather events, such as flooding, hurricanes, or heat waves. Resilient design incorporates strategies like flood-resistant construction, raising buildings above flood zones or using materials that can withstand water exposure. Heat island mitigation, using reflective or green roofing materials to reduce the urban heat island effect, where cities become significantly warmer than surrounding rural areas due to human activity and infrastructure. Energy resilience, incorporating renewable energy sources like solar and wind power to reduce reliance on the grid, which can be unreliable during extreme weather events. Carbon emissions and the built environment. Buildings and construction contribute significantly to global greenhouse gas (GHG) emissions, primarily through energy consumption during operation and embodied carbon in building materials. According to the World Green Building Council, the building and construction sector is responsible for nearly 40% of global energy-related CO2 emissions. Sustainable design addresses this issue by reducing operational emissions, using energy-efficient systems such as insulation, LED lighting, and renewable energy sources like solar panels. Minimizing embodied carbon, choosing materials with low carbon footprints such as sustainably sourced timber, recycled metals, or low-carbon concrete alternatives. Example: the Bullitt Center in Seattle, often referred to as the greenest commercial building in the world, uses solar panels, geothermal heating, and rainwater harvesting to reduce its carbon footprint, demonstrating how design can reduce the environmental impact of buildings. Material sourcing and environmental implications. One of the most significant environmental impacts of design lies in the materials used to create products, buildings, and infrastructure. The extraction, transportation, and processing of raw materials can have substantial ecological consequences, including habitat destruction, resource depletion, and pollution. Sustainable material choices. To reduce environmental harm, sustainable design advocates for the use of materials that are renewable, recyclable, or have a minimal ecological footprint. Designers are increasingly turning to materials that are renewable. Materials like bamboo, cork, or rapidly regenerating timber are renewable resources that can be replenished within a short period. Are recyclable or biodegradable. Materials like aluminum, glass, and certain plastics can be recycled indefinitely, while organic materials like hemp or wool are biodegradable and return to the environment without lasting harm. Have low embodied energy. Embodied energy refers to the energy consumed during the extraction, processing, transportation, and disposal of materials. Sustainable materials have lower embodied energy, meaning less energy is required throughout their life cycle. Ethical sourcing. Sourcing materials ethically is another key component of sustainable design. This involves ensuring that materials are sourced responsibly, with respect for ecosystems, human rights, and local communities. Designers can opt for certified sustainable materials. Materials certified by organizations like the Forest Stewardship Council, FSC, for wood products, or Fair Trade certified materials ensure that resources are harvested in an environmentally and socially responsible manner. Avoid conflict materials. Materials like certain metals and minerals, e.g. coltan, may contribute to human rights abuses in conflict zones. Ethical sourcing ensures that these materials are not part of the supply chain. Example: Patagonia, the outdoor clothing brand, uses recycled materials in its clothing products, including recycled polyester and wool, which reduces the need for virgin resources and decreases the overall environmental impact of their manufacturing process. Reducing carbon footprints in design. Carbon footprints are a crucial metric for evaluating the environmental impact of a product, system, or building. They refer to the total amount of greenhouse gases (GHGs) emitted during the life cycle of a product, including carbon dioxide (CO2), methane (CH4), and nitrous oxide (N2O). Reducing carbon footprints is central to sustainable design, as it directly addresses the problem of global warming. Strategies for reducing carbon footprints in design. Energy-efficient design. One of the most effective ways to reduce carbon emissions is to design energy-efficient buildings and products. This can include passive design strategies, such as maximizing natural light and ventilation, or using energy-efficient appliances, insulation, and heating cooling systems. Low-carbon materials. As mentioned earlier, selecting materials with low embodied carbon is an essential step in reducing carbon footprints. This includes using recycled materials or sustainable alternatives to energy-intensive materials like cement and steel. Carbon offsetting. For some projects, it may not be possible to eliminate all carbon emissions. In these cases, designers can invest in carbon offset projects, such as reforestation or renewable energy projects, to compensate for their remaining emissions. Example: the Edge Olympic Stadium in London, built for the 2012 Summer Olympics, used low-carbon materials and energy-efficient systems to reduce its carbon footprint. The stadium's design helped ensure it met the goal of being one of the most sustainable Olympic venues in history. Design for biodiversity and ecosystem preservation. Sustainable design must also consider the impact on biodiversity and ecosystems. As human activity continues to alter landscapes through urbanization and industrial development, many ecosystems are being disrupted, leading to a decline in biodiversity. Sustainable design seeks to minimize habitat destruction. Through careful planning and material selection, sustainable design aims to reduce the impact on natural habitats and local wildlife. This can include preserving natural landscapes during construction or integrating green spaces into urban environments. Enhance biodiversity. Designers can use techniques like green roofs, vertical gardens, and wildlife corridors to help support local ecosystems and promote biodiversity in urban areas. Promote sustainable agriculture. In product design, sustainable practices extend to the sourcing of agricultural products. Choosing organic, locally grown, and sustainably farmed materials can help protect ecosystems and reduce the environmental impact of farming practices. Example: the Bosco Verticale vertical forest in Milan, Italy, is a pair of residential towers designed with thousands of trees, shrubs, and plants integrated into the facade. This design not only provides a habitat for birds and insects, but also helps reduce air pollution and mitigate the urban heat island effect. Waste reduction and circular design. Waste is a significant environmental issue, and reducing it is a core principle of sustainable design. One of the most effective ways to address waste is through circular design, a concept that focuses on extending the life of products and materials by creating systems that keep resources in use for as long as possible. Principles of circular design. Design for durability, creating products that are built to last rather than products that are designed to be disposable or to break easily. Design for disassembly, products that can be easily disassembled at the end of their life allow for the reuse and recycling of materials, reducing waste. Upcycling, turning waste materials into valuable products. For example, using discarded plastic bottles to create new clothing or furniture. Example: the circular design approach is exemplified by the Adidas x Parley partnership, where Adidas creates shoes made from recycled ocean plastic, preventing these materials from entering landfills and the oceans while creating a functional product. Conclusion: designing for the planet. The environmental impacts of design decisions cannot be overstated. Climate change, resource depletion, and biodiversity loss are urgent global challenges that demand a redesign of the way we think about and create the products, buildings, and systems that make up our world. By incorporating ecological considerations into every design phase, from material selection and energy efficiency to carbon footprint reduction and biodiversity preservation, we can mitigate these impacts and move toward a more sustainable future. Designers have the power to influence change by making decisions that support environmental health and planetary well-being. As sustainable design principles continue to evolve and new technologies emerge, the opportunities to create a more sustainable world are vast. Part 4: Sustainable Design in Architecture. The role of architecture in sustainable design. Architecture plays a significant role in the pursuit of sustainability, as buildings account for a substantial portion of global energy consumption, carbon emissions, and resource use. The built environment, which includes homes, offices, schools, hospitals, and other infrastructure, influences not only how people interact with their surroundings, but also the long-term health of the planet. Sustainable architecture aims to minimize the environmental impact of buildings by employing strategies that enhance energy efficiency, reduce resource consumption, improve indoor air quality, and create environments that promote the well-being of occupants. The essence of sustainable architecture lies in designing buildings that are energy efficient, resilient to climate change, and integrated with the natural environment. Architects have the power to shape cities and communities that work in harmony with nature, creating structures that not only serve human needs, but also contribute positively to the ecosystem. Sustainable architecture also emphasizes social sustainability by creating spaces that support social interaction, inclusivity, and long-term livability. Key principles of sustainable architecture. The principles of sustainable architecture are rooted in a holistic approach to design, considering environmental, social, and economic factors. Some of the core principles include energy efficiency. Energy-efficient buildings minimize the amount of energy required for heating, cooling, lighting, and other operations. This is achieved through the use of passive design strategies, such as natural ventilation and orientation, as well as energy-efficient technologies, such as solar panels, LED lighting, and high-efficiency HVAC systems. Passive design. Using the building's design, materials, and orientation to maximize natural light, reduce heat gain, and provide natural ventilation. Active systems. Incorporating renewable energy technologies like solar panels, wind turbines, or geothermal heating to reduce the reliance on fossil fuels. Water conservation. Sustainable architecture prioritizes water-efficient systems to reduce the strain on local water supplies. These can include low-flow fixtures, rainwater harvesting systems, and greywater recycling systems, which help buildings become more self-sufficient when it comes to water use. Water-efficient fixtures, toilets, faucets, and showerheads that use less water without sacrificing performance. Rainwater harvesting, collecting and storing rainwater for use in irrigation, cooling, or non-potable applications. Material selection. The selection of materials plays a crucial role in reducing the environmental impact of a building. Sustainable architecture seeks to use materials that are locally sourced, reducing the carbon footprint associated with transportation and supporting local economies. Renewable, using materials that can be replenished naturally, like bamboo or cork. Recyclable or reusable, choosing materials that can be recycled or repurposed at the end of their life cycle. Indoor environmental quality. Sustainable buildings prioritize the health and comfort of their occupants by improving indoor air quality, natural lighting, and acoustics. This includes minimizing the use of toxic materials, incorporating natural ventilation, and ensuring that spaces are well lit and comfortable. Non-toxic materials. Using paints, finishes, and materials that do not emit harmful chemicals into the indoor environment. Natural lighting. Maximizing the use of daylight through thoughtful window placement and light-colored surfaces that reflect sunlight. Waste reduction. Sustainable architecture aims to reduce waste, both during the construction phase and throughout the building's life cycle. This can involve designing for disassembly, using materials that are durable and long-lasting, and incorporating systems that allow for recycling and reusing materials. Construction waste management. Implementing strategies to reduce, reuse, and recycle construction debris. Design for disassembly. Creating buildings that can be easily deconstructed and their materials reused or recycled. Strategies for sustainable architecture. There are several strategies that architects and designers use to create more sustainable buildings. These strategies range from fundamental design concepts to innovative technologies that help achieve environmental goals. Some of the most prominent strategies include passive solar design. Passive solar design is one of the oldest and most effective methods of creating energy-efficient buildings. It involves designing the building's orientation, windows, and insulation to maximize natural heating and cooling, minimizing the need for mechanical systems. Key elements of passive solar design include orientation, positioning the building to take advantage of solar exposure and prevailing winds. Thermal mass, using materials that absorb and store heat during the day and release it at night, reducing the need for heating or cooling. Shading, using overhangs, awnings, and landscaping to block excessive heat gain from the sun during the summer months while allowing solar gain in the winter. Green roofing, green roofs, also known as living roofs, are an increasingly popular way to integrate nature into the built environment. They provide insulation, reduce stormwater runoff, improve air quality, and create habitats for wildlife. In addition, green roofs help mitigate the urban heat island effect by absorbing sunlight and reducing the amount of heat retained by conventional roofs. Vegetative cover, planting a variety of grasses, herbs, and even small trees on rooftops to provide insulation and improve aesthetics. Stormwater management, using the green roof to capture rainwater and reduce the burden on drainage systems. Building integrated renewable energy systems, incorporating renewable energy systems directly into building design, is an effective way to reduce a building's reliance on fossil fuels. Solar panels, wind turbines, and geothermal energy systems can be integrated into a building's design to generate electricity, heat water, or provide space heating and cooling. Solar panels, installing photovoltaic (PV) panels on rooftops or building facades to generate electricity. Wind turbines, using small-scale wind turbines to harness wind energy in areas where wind is a viable resource. Geothermal systems, using the Earth's natural temperature to heat and cool buildings through ground-source heat pumps. Net zero energy design. Net zero energy buildings, NZEBs, are designed to produce as much energy as they consume over the course of a year. This can be achieved through a combination of energy-efficient design strategies and on-site, renewable energy generation. In addition to reducing energy demand, net zero energy buildings may even produce surplus energy that can be fed back into the grid. Energy-efficient envelope, ensuring the building's walls, roof, windows, and doors are highly insulated and airtight to minimize energy loss. On-site renewable energy generation, installing solar panels or wind turbines to produce clean energy on-site. Green building certifications and standards. Several certification programs and standards have been developed to help guide and evaluate the sustainability of buildings. These programs provide frameworks for architects and designers to follow, ensuring that their projects meet specific environmental criteria. Some of the most widely recognized green building certifications include LEED, Leadership in Energy and Environmental Design. LEED is one of the most widely used green building certification systems in the world. Developed by the U.S. Green Building Council, USGBC, it evaluates buildings based on various criteria, including energy performance, water conservation, indoor environmental quality, and material selection. Buildings are awarded points in different categories and can achieve different levels of certified, silver, gold, or platinum. BREEAM, Building Research Establishment Environmental Assessment Method. BREEAM is a UK-based certification system that evaluates the sustainability of buildings in terms of energy efficiency, water use, material sourcing, waste management, and more. Like LEED, BREEAM awards points across multiple categories, with the goal of reducing the environmental impact of buildings. Living Building Challenge. The Living Building Challenge is an ambitious green building certification that aims for the highest level of sustainability. It focuses on creating buildings that generate their own energy, capture and treat water, and use non-toxic locally sourced materials. Living buildings must also meet social equity and community engagement criteria, making it a holistic certification that addresses environmental, economic, and social sustainability. WELL Building Standard. The WELL Building Standard focuses on the health and well-being of building occupants. It evaluates factors such as air quality, lighting, acoustics, and access to nature, all of which contribute to the physical and mental health of those who live or work in the building. Case studies in sustainable architecture. The Edge, Amsterdam, Netherlands. The Edge is a highly innovative office building in Amsterdam that is often considered one of the greenest office buildings in the world. It uses a combination of renewable energy sources, smart technology, and energy-efficient design strategies to minimize its environmental impact. The building features solar panels, a green roof, and an intelligent building management system that optimizes energy use. It also provides employees with an environment that promotes health and productivity through natural lighting, excellent air quality, and access to green spaces. The Bosco Verticale, Milan, Italy, also known as the Vertical Forest. The Bosco Verticale consists of 2 residential towers that are home to over 9,000 trees, 5,000 plants, and 13,000 shrubs. This green architecture project helps mitigate air pollution, reduce energy consumption by insulating the building, and provide habitat for urban wildlife. The towers also address the issue of urban heat islands by increasing the amount of greenery in the city. The Crystal, London, UK. The Crystal is a sustainable building that functions as both a conference center and a public exhibition space. It is powered by renewable energy, utilizes advanced energy-efficient technologies, and features a green roof. The building is also one of the first in the UK to achieve BREEAM Outstanding status, demonstrating its commitment to environmental sustainability. Conclusion: the future of sustainable architecture. Sustainable architecture is essential for addressing the environmental challenges of the 21st century. By adopting principles of energy efficiency, water conservation, and material sustainability, architects can design buildings that reduce their impact on the planet while improving the quality of life for those who inhabit them. The future of architecture lies in buildings that are not only beautiful and functional, but also resilient, energy efficient, and integrated with nature. As the demand for sustainable buildings continues to grow, architects and designers will play a pivotal role in shaping the future of cities, communities, and the environment. Sustainable architecture is not just about creating green buildings, it is about reimagining the relationship between the built environment and the natural world, ensuring that design contributes to the long-term health and sustainability of the planet. Part 5. Sustainable design in product design and manufacturing. The role of product design in sustainability. Product design is a key component of sustainability because it directly impacts resource consumption, waste generation, and energy use over a product's life cycle. Every product, from household items to electronics and clothing, consumes resources during manufacturing, use, and disposal. Sustainable product design aims to reduce these environmental impacts by incorporating eco-friendly principles from the very beginning of the design process. Sustainable product design seeks to create products that minimize environmental harm, improve the well-being of users, and promote the efficient use of resources. As the world becomes increasingly concerned with climate change, resource depletion, and pollution, manufacturers and designers must innovate solutions that balance performance, longevity, and environmental responsibility. Principles of sustainable product design. Several guiding principles serve as the foundation for sustainable product design. These principles are aimed at reducing the environmental impact of products throughout their life cycle. Minimizing material use. Sustainable product design seeks to minimize the amount of material needed to produce a product. This can be achieved by optimizing designs, streamlining designs to eliminate excess materials while ensuring the product remains functional and durable. Lightweighting, reducing the weight of the product through material selection or design methods without sacrificing strength or performance. Material selection, choosing the right materials is one of the most significant ways to improve the sustainability of a product. Sustainable designers prioritize renewable materials, materials that can be replenished quickly, such as bamboo, cork, or hemp, over non-renewable materials like plastics derived from fossil fuels. Recycled and recyclable materials. Using materials that can be recycled into new products at the end of their life cycle, such as recycled aluminum, glass, or plastic. Non-toxic materials. Avoiding materials that release harmful chemicals or pollutants, such as certain flame retardants or toxic dyes. Designed for durability and longevity. Products that are durable and long-lasting have a reduced environmental impact because they do not need to be replaced as frequently. Sustainable designers focus on creating products that are robust, made to last through heavy use and normal wear and tear. Can be repaired. Products that can be easily fixed or maintained to extend their lifespan rather than being disposed of when something breaks. Modular and disassemblable design. Creating products that are modular or easy to disassemble promotes the reuse and recycling of components. This can include replaceable parts, allowing parts to be replaced without needing to discard the entire product. Easily separable materials. Designing products so that different materials can be easily separated for recycling, reducing contamination and improving recycling efficiency. Minimizing energy consumption. Sustainable products are designed to consume less energy during their use phase. This is particularly important for products such as electronics, appliances, and vehicles. Techniques include energy-efficient operation. Products designed to use less energy during operation, such as energy-saving home appliances or low-power electronics. Renewable energy use. Some products, like solar-powered chargers or battery packs, are designed to use renewable energy, reducing dependence on fossil fuels. End-of-life considerations. Sustainable design doesn't stop once a product is made, it extends to the end of a product's life. Designers consider recycling. Creating products that can be easily recycled at the end of their life, minimizing the amount of waste sent to landfills. Upcycling. Using materials from old products to create new products of higher value. Sustainable manufacturing practices. The environmental impact of product design is not limited to the products themselves. The manufacturing process is equally significant. Sustainable manufacturing aims to reduce the negative environmental impacts associated with the production of goods by improving resource efficiency, reducing waste, and minimizing energy consumption. Some of the most important sustainable manufacturing practices include energy efficiency. Manufacturers are increasingly adopting energy-efficient technologies to reduce their carbon footprint. This includes the use of renewable energy sources like solar or wind power in production facilities, as well as upgrading machinery to be more energy efficient. Energy recovery. Using waste heat from production processes to generate additional energy, reducing the need for external power sources. Smart energy management systems. Monitoring and optimizing energy use in real time to avoid waste and improve efficiency. Water efficiency. Reducing water use is crucial for industries that require large amounts of water in their manufacturing processes. Water-efficient practices might include water recycling. Recycling water used in manufacturing processes to minimize the need for fresh water. Closed-loop water systems. Creating systems that reduce water waste by circulating it through a closed loop instead of discharging it into the environment. Waste minimization. Sustainable manufacturing aims to reduce waste generated during production by implementing practices such as zero waste to landfill. Designing manufacturing processes that eliminate waste, recycle materials, and prevent products or byproducts from being sent to landfills. Lean manufacturing. Using lean production techniques to minimize material waste, streamline processes, and increase productivity. Green packaging. Packaging is often an overlooked aspect of sustainability, but it plays a significant role in reducing the overall environmental impact of a product. Green packaging practices include minimal packaging. Reducing the amount of packaging used without compromising product protection or user experience. Eco-friendly materials. Using biodegradable, recyclable, or compostable materials for packaging. Designing for easy recycling, ensuring that packaging materials can be easily separated and recycled. Case studies in sustainable product design. To better understand how sustainable design principles are applied in real-world scenarios, here are a few examples of products that embody sustainability in their design. Fairphone, sustainable smartphone. The Fairphone is designed with the intention of reducing e-waste and promoting fair labor practices. It is modular, meaning users can replace individual components like the battery, screen, or camera, rather than discarding the entire phone. The phone's materials are sourced from conflict-free regions, and it is built with ethical manufacturing practices in mind. The Fairphone's repairability and longevity contribute to a significant reduction in e-waste. Patagonia, sustainable outdoor apparel. Patagonia is renowned for its commitment to sustainability in both product design and manufacturing. The company uses recycled materials in its clothing, including recycled polyester and wool, and sources wool and down through responsible supply chains. Patagonia also offers repair services for their products, encouraging customers to fix rather than replace their items. Furthermore, the company promotes an eco-friendly worn-wear program where customers can buy used items and trade in their old gear. Tesla electric vehicles. Tesla's electric vehicles, EVs, are designed to reduce the environmental impact of transportation. Tesla's EVs are powered by electricity instead of fossil fuels, reducing carbon emissions during operation. Additionally, the company's cars are designed to be energy efficient, with cutting-edge battery technology and aerodynamic designs to optimize energy use. Tesla also focuses on creating vehicles that are long-lasting, reducing the need for frequent replacements. IKEA, circular product design. IKEA has made significant strides in sustainable design, particularly through its focus on circularity. The company has committed to using more sustainable materials, such as recycled wood, plastic, and cotton in its products. Additionally, IKEA is experimenting with furniture designs that can be easily disassembled for reuse or recycling. In the future, the company plans to introduce services that allow customers to return used furniture for recycling or repurposing. The future of sustainable product design. As the global demand for sustainable products increases, the future of product design will undoubtedly be shaped by further innovations in sustainability. Key trends that are likely to shape the future of sustainable design include cradle-to-cradle design. The cradle-to-cradle approach envisions a closed-loop system in which products are designed from the outset to be reused, remanufactured, or recycled, eliminating waste entirely. This approach emphasizes the continuous flow of materials and the creation of products that can be endlessly recycled. 3D printing and additive manufacturing. 3D printing has the potential to revolutionize sustainable design by enabling on-demand production, reducing material waste, and allowing for more efficient use of resources. This method of manufacturing allows products to be created with precise material specifications, reducing the need for excess production and transportation. Biodegradable materials. As research into sustainable materials progresses, the development of biodegradable materials could reduce the environmental impact of products, especially those that are single-use or disposable. These materials break down naturally, reducing the amount of plastic waste that ends up in landfills and oceans. Circular business models. Companies are increasingly moving toward circular business models, where products are designed with a focus on reuse and recycling. Subscription-based services, product repair, and leasing models are being explored as alternatives to the traditional model of ownership, which often leads to waste. Conclusion: designing for a sustainable future. Sustainable product design and manufacturing are essential to addressing global challenges like climate change, resource depletion, and waste management. By incorporating eco-friendly materials, energy-efficient systems, and circular design principles, designers can create products that are not only functional and beautiful, but also environmentally responsible. The future of product design will see further integration of sustainable practices, with advances in materials science, manufacturing technologies, and design strategies playing a key role in reducing the environmental footprint of products. As consumers become more conscious of their purchasing decisions, there will be a growing demand for products that prioritize sustainability, paving the way for a greener, more responsible future. Part 6. Sustainable Design in Urban Planning and Development. The importance of sustainable urban planning. Urban planning has a profound influence on the sustainability of cities and communities. As the global population grows and more people live in urban areas, cities are responsible for a significant portion of the world's energy consumption, waste production, and greenhouse gas emissions. Sustainable urban planning seeks to address these challenges by creating environments that are resource efficient, resilient to climate change, and conducive to the well-being of all residents. The goal of sustainable urban planning is to design cities that are not only environmentally responsible, but also socially inclusive and economically viable. This approach emphasizes the integration of green spaces, efficient transportation systems, affordable housing, and the use of sustainable technologies to create thriving urban ecosystems. By adopting sustainable urban planning practices, cities can reduce their ecological footprint while improving the quality of life for residents. Principles of sustainable urban planning. Sustainable urban planning incorporates a variety of principles aimed at fostering livable, resilient, and eco-friendly cities. Key principles include compact and mixed-use development. One of the central tenets of sustainable urban planning is the concept of compact cities. This involves designing urban areas that are dense and well-connected, reducing urban sprawl, and minimizing the need for extensive infrastructure. Mixed-use zoning, integrating residential, commercial, and recreational spaces to encourage walkability, reduce the reliance on cars, and foster vibrant communities. Urban infill, developing underutilized or vacant land within cities instead of expanding outward, which helps preserve natural habitats and reduce urban sprawl. Sustainable transportation systems. Efficient and sustainable transportation is crucial for reducing a city's carbon footprint. Sustainable urban planning encourages the development of transportation systems that minimize emissions, reduce congestion, and provide alternatives to car-dependent travel. Public transit. Expanding and improving public transit systems, such as buses, trains, and subways, to provide affordable, accessible, and low-emission alternatives to private cars. Cycling and walking. Designing cities with pedestrian-friendly streets, bike lanes, and public spaces that promote active transportation, reducing traffic congestion and improving air quality. Electric vehicles, EVs. Supporting the adoption of electric vehicles through infrastructure such as EV charging stations and incentives for sustainable transportation options. Energy efficiency and renewable energy. Sustainable urban planning aims to reduce energy consumption and reliance on fossil fuels by integrating renewable energy sources and promoting energy-efficient infrastructure. Green buildings. Encouraging the construction of energy-efficient buildings using passive solar design, high-performance insulation, and renewable energy systems such as solar panels and wind turbines. District energy systems. Implementing district heating and cooling systems to provide energy-efficient, centralized heating and cooling to multiple buildings within an area. Renewable energy integration. Integrating renewable energy sources, such as solar, wind, and geothermal, into urban infrastructure to reduce reliance on non-renewable energy sources. Green spaces and biodiversity. Incorporating green spaces and preserving biodiversity is essential for creating sustainable and resilient cities. Green spaces provide numerous benefits, including improving air quality, reducing the urban heat island effect, and enhancing residents' physical and mental well-being. Parks and green corridors. Designing parks, urban forests, and greenways that connect neighborhoods and promote biodiversity. Urban agriculture. Supporting local food production through community gardens, rooftop farms, and urban farming initiatives that reduce the carbon footprint of food transportation and promote food security. Biodiversity conservation, protecting and restoring natural habitats within urban areas to support wildlife and improve ecological health. Water conservation and management, sustainable urban planning emphasizes efficient water use and management to conserve resources, reduce pollution, and prevent flooding. Water-efficient infrastructure, designing buildings, landscapes, and urban systems that minimize water usage, such as low-flow fixtures, rainwater harvesting, and greywater recycling systems. Stormwater management, implementing sustainable urban drainage systems (SUDs), such as permeable pavements, green roofs, and bioswales to manage stormwater, reduce runoff, and prevent flooding. Water recycling and reuse, encouraging the use of treated wastewater for non-potable purposes, such as irrigation or industrial use, to reduce the demand on freshwater sources. Social equity and inclusivity, a sustainable city is one that is socially equitable and inclusive, providing opportunities for all residents regardless of their socioeconomic status to thrive. Affordable housing, ensuring that housing is affordable and accessible to all members of society, with a focus on providing safe and healthy living conditions for low-income communities. Community engagement, involving residents in the planning process to ensure that the development meets the needs of the community and fosters a sense of ownership and participation. Equitable access to services, ensuring that all residents have access to basic services such as healthcare, education, transportation, and recreational facilities. Sustainable infrastructure and green buildings. The construction of sustainable infrastructure and green buildings is a fundamental aspect of sustainable urban planning. Green buildings are designed to be energy efficient, environmentally friendly, and conducive to the well-being of their occupants. Several strategies contribute to the creation of green buildings and sustainable infrastructure. Energy-efficient building designs. Green buildings are built to minimize energy consumption and optimize energy use. This can include passive design, designing buildings to take advantage of natural light, solar heat, and ventilation, reducing the need for artificial lighting and heating. High-performance insulation, using advanced materials that minimize heat loss in winter and reduce heat gain in summer, improving the building's overall energy efficiency. Smart technologies, implementing smart building systems that optimize heating, cooling, and lighting based on occupancy and external conditions, reducing energy waste. Sustainable construction materials. Green buildings use sustainable construction materials that are renewable, locally sourced, and non-toxic. Some examples include recycled and reclaimed materials, using materials that have been reused from previous buildings or industrial processes, reducing the need for new resources and minimizing waste. Sustainable timber, sourcing timber from responsibly managed forests or using alternative materials such as bamboo, which grows rapidly and can be harvested sustainably. Low-emission materials, choosing materials that emit fewer pollutants during production and use, such as low VOC paints and finishes. Green infrastructure. Green infrastructure refers to the network of natural and semi-natural systems that provide ecosystem services in urban areas. This includes green roofs and walls, installing plants on rooftops and walls to improve insulation, reduce the urban heat island effect, and support biodiversity. Urban wetlands, restoring or creating wetlands in urban areas to manage stormwater, filter pollutants, and provide habitats for wildlife. Tree canopies and urban forests, planting and maintaining trees and forests to provide shade, improve air quality, and mitigate climate change impacts. Case studies in sustainable urban planning. To better understand the implementation of sustainable urban planning, we can examine some successful examples of sustainable cities and neighborhoods around the world. Copenhagen, Denmark. Copenhagen is one of the world's most sustainable cities, with a strong commitment to reducing carbon emissions and improving quality of life. The city has invested heavily in cycling infrastructure, with over 40% of Copenhageners using bicycles for their daily commute. Additionally, Copenhagen aims to become the world's first carbon-neutral city by 2025, with initiatives focused on renewable energy, energy-efficient buildings, and green transportation. Vauban, Germany. Vauban is a sustainable neighborhood in Freiburg, Germany, known for its commitment to energy efficiency, renewable energy, and car-free living. The neighborhood features passive solar homes, a district heating system, and extensive green spaces. Vauban's car-free design encourages residents to use public transportation, bicycles, and walking as their primary modes of transport. Songdo, South Korea. Songdo is a smart city built from the ground up with sustainability in mind. It features energy-efficient buildings, advanced waste management systems, and extensive green spaces. The city also uses cutting-edge technology to manage traffic, energy consumption, and waste, making it one of the most innovative and sustainable urban developments in the world. Melbourne, Australia. Melbourne has made significant strides in sustainable urban planning through its Green Your Laneways initiative, which transforms underutilized urban spaces into green, walkable, and environmentally friendly areas. The city also focuses on water conservation, green roofs, and sustainable public transportation to improve the urban environment and reduce its ecological footprint. The future of sustainable urban planning. As urbanization continues to accelerate, the future of cities will depend on the widespread adoption of sustainable urban planning practices. Emerging trends and innovations are shaping the next generation of sustainable cities. Smart cities and digital technologies. The integration of digital technologies into urban planning allows for more efficient resource management, from traffic control to energy distribution. Smart cities use data to optimize everything from public transportation to waste management, creating more livable and efficient urban environments. Resilient and climate-adaptive cities. Cities must become more resilient to the impacts of climate change, including rising sea levels, extreme weather events, and temperature fluctuations. Future urban planning will focus on designing cities that can adapt to these challenges by incorporating climate-resilient infrastructure, flood control systems, and heat mitigation strategies. Circular cities. Circular urban design focuses on eliminating waste and creating systems that allow for the continual reuse of resources. Cities of the future will be designed with a closed-loop approach, where materials, products, and waste are continuously repurposed, reducing the need for virgin resources and minimizing environmental impacts. Conclusion: shaping sustainable cities for the future. Sustainable urban planning is essential to addressing the environmental, social, and economic challenges of modern cities. By prioritizing energy efficiency, sustainable transportation, green infrastructure, and social equity, urban planners can create cities that are resilient, resource-efficient, and livable for all residents. As cities continue to grow, sustainable urban planning will play a pivotal role in shaping the future of our built environment and ensuring that urban areas are prepared for the challenges of the coming decades. Part 7. Sustainable Design in Agriculture and Food Systems. The role of sustainable design in agriculture. Agriculture plays a vital role in feeding the global population, but traditional farming methods can contribute significantly to environmental degradation. From deforestation and soil erosion to excessive water use and greenhouse gas emissions, conventional agricultural practices often come at a high environmental cost. As the global population grows, it becomes increasingly important to adopt sustainable design principles in agriculture to meet food production needs without compromising the health of the planet. Sustainable agriculture involves farming techniques that reduce environmental impact, conserve natural resources, and ensure the long-term viability of food production. By focusing on soil health, biodiversity, water conservation, and energy efficiency, sustainable agricultural practices help mitigate the effects of climate change, protect ecosystems, and create resilient food systems for future generations. Principles of sustainable agriculture. Sustainable agriculture focuses on achieving environmental economic and social sustainability through farming practices that are ecologically sound, economically viable, and socially just. The key principles of sustainable agriculture include soil health and conservation. Soil is the foundation of agricultural productivity, but conventional farming practices often lead to soil depletion and erosion. Sustainable agricultural practices prioritize the health and longevity of soil, including crop rotation, rotating different crops on the same land to prevent soil depletion and break pest cycles. Cover cropping, planting cover crops such as legumes to improve soil fertility, reduce erosion, and promote biodiversity. No-till farming, minimizing soil disturbance by avoiding plowing, which helps maintain soil structure, conserve moisture, and reduce erosion. Composting, using organic waste to improve soil health by adding nutrients and increasing soil organic matter. Water conservation and management. Water is one of the most precious resources in agriculture, but inefficient water use can lead to water shortages, contamination, and resource depletion. Sustainable agriculture incorporates water management strategies that prioritize efficiency and conservation. Drip irrigation, using a low-pressure, precise system to deliver water directly to plant roots, minimizing waste and runoff. Rainwater harvesting, capturing and storing rainwater for irrigation, reducing dependence on groundwater and municipal water systems. Watershed management, implementing practices that protect natural watersheds and ensure clean, reliable water sources for agricultural needs. Water-efficient crops, selecting drought-tolerant and water-efficient crop varieties that require less water for growth. Biodiversity and ecosystem conservation. Biodiversity is essential for maintaining healthy and resilient agricultural systems. Sustainable agriculture aims to protect ecosystems and promote biodiversity through practices such as agroforestry, integrating trees and other plants into agricultural landscapes to enhance biodiversity, improve soil fertility, and provide habitats for wildlife. Polyculture, growing multiple crop species in a single field to mimic natural ecosystems, improve soil health, and reduce the risk of pest infestations. Habitat conservation, protecting natural habitats, wetlands, and wildlife corridors within farming areas to preserve biodiversity and promote ecosystem services. Energy efficiency and renewable energy. Agriculture is a significant consumer of energy, particularly through the use of fossil fuels in irrigation, machinery, and transport. Sustainable agriculture seeks to reduce energy consumption by efficient machinery, using energy-efficient tractors, harvesters, and irrigation systems that reduce fuel consumption. Renewable energy, harnessing renewable energy sources such as solar, wind, and biogas for on-farm energy needs, reducing reliance on fossil fuels. Energy-efficient greenhouses, using passive solar heating, natural ventilation, and energy-efficient lighting in greenhouse farming. Waste reduction and recycling. Reducing waste is a key component of sustainable agriculture, as food production often generates substantial amounts of waste. Sustainable practices focus on minimizing waste and recycling organic matter. Composting organic waste, converting agricultural residues and food waste into compost to enrich the soil and reduce landfill waste. Utilizing byproducts, repurposing agricultural byproducts, such as crop residues or animal manure, for energy production or as organic fertilizers. Zero-waste farms, striving for a farm-to-table model where every resource, including waste, is used efficiently and nothing goes to waste. Sustainable food systems, from farm to table. Sustainable food systems involve redesigning how food is grown, processed, distributed, and consumed to reduce environmental impact and promote social equity. Creating a sustainable food system requires collaboration among farmers, manufacturers, retailers, and consumers. Key components of sustainable food systems include local and seasonal food production. One of the most effective ways to reduce the environmental impact of food is to consume locally grown seasonal produce. By reducing the distance food travels from farm to table, we can decrease transportation-related emissions and support local economies. Community-supported agriculture (CSA). This model involves consumers purchasing shares of a local farm's harvest, ensuring fresh, seasonal produce while supporting small-scale farmers. Farmers' markets. Direct sales from farmers to consumers reduce the need for packaging, long transportation distances, and refrigeration, making food more sustainable. Sustainable food processing and packaging. Food processing and packaging can generate significant waste and pollution. Sustainable food systems prioritize eco-friendly processing and packaging methods, including minimal processing, reducing the amount of energy, water, and additives used in food processing to retain the nutritional value of the food. Eco-friendly packaging, using biodegradable, recyclable, or reusable packaging to reduce plastic waste. Innovations like edible packaging and compostable materials are helping to minimize the environmental footprint of food packaging. Food preservation, using sustainable methods such as fermentation, drying, or canning to extend the shelf life of food while minimizing the need for refrigeration. Sustainable consumption. Consumers play a crucial role in creating sustainable food systems by making informed choices about the food they purchase and consume. Strategies to promote sustainable consumption include plant-based diets, reducing meat and dairy consumption, especially from industrial animal agriculture, which has a large environmental footprint. Plant-based foods generally require fewer resources and have a lower carbon footprint. Food waste reduction, promoting conscious consumption and reducing food waste by planning meals using leftovers and composting food scraps. Fair trade and ethical sourcing, supporting companies and farmers that use ethical labor practices and prioritize environmental sustainability in their production methods. Case studies in sustainable agriculture and food systems. Several examples of sustainable agricultural practices and food systems provide inspiration and models for wider adoption. These case studies demonstrate how sustainable design principles can be integrated into agriculture at different scales. The Rodale Institute, USA. The Rodale Institute is a leader in organic farming research and has been promoting sustainable agricultural practices for decades. Through its farming trials and research, the Institute has shown that organic farming practices, such as crop rotation, composting, and reduced pesticide use, can be as productive as conventional farming while improving soil health, increasing biodiversity, and reducing the environmental impact. The Land Institute, USA. The Land Institute is pioneering the development of perennial grain crops that can be grown without annual replanting, thus reducing soil erosion and the need for synthetic fertilizers. Their research focuses on breeding crops such as kernza, a perennial wheatgrass, which offers long-term sustainability benefits and is more resilient to climate change than traditional annual crops. Sustainable Agriculture Network. SAN is a global organization that promotes sustainable farming practices by providing certification to farmers who meet environmental and social criteria. Their certification system, known as Rainforest Alliance certification, helps consumers identify sustainably produced goods such as coffee, cocoa, and bananas, while supporting smallholder farmers and improving the livelihoods of farming communities. Biomimicry in agriculture. Global biomimicry is an innovative approach that draws inspiration from nature to solve human challenges. In agriculture, biomimicry involves designing farming systems that mimic natural ecosystems. Examples include creating polycultures that simulate natural biodiversity and using nature's pest control methods, such as encouraging predator species or introducing beneficial insects to control pests rather than relying on chemical pesticides. The future of sustainable agriculture and food systems. The future of sustainable agriculture and food systems is rooted in innovation and collaboration. The following trends are expected to shape the future of food production. Agritech and precision farming. Technology is playing an increasingly important role in making agriculture more sustainable. Precision farming involves the use of data, sensors, and machine learning to optimize irrigation, fertilization, and pest management, reducing resource use and increasing yields. Drones, satellite imaging, and autonomous tractors are also helping farmers monitor crops more efficiently and apply resources more accurately. Vertical farming and urban agriculture. As cities grow, the need for sustainable food production within urban areas is becoming more pressing. Vertical farming and urban agriculture involve growing food in stacked layers or repurposed urban spaces, such as rooftops or vacant lots. These systems can reduce transportation costs, increase local food availability, and utilize renewable energy sources. Regenerative agriculture. Regenerative agriculture goes beyond sustainability to restore and improve the health of the land. It focuses on building soil fertility, increasing biodiversity, and enhancing ecosystem services such as carbon sequestration and water retention. Regenerative practices, such as holistic grazing and agroecology, are gaining traction as farmers look for ways to create long-term sustainability while improving productivity. Conclusion: designing a sustainable food future. Sustainable design in agriculture and food systems is critical to addressing the challenges posed by climate change, resource depletion, and food insecurity. By adopting sustainable agricultural practices, promoting local and seasonal food production, and reducing waste, we can create food systems that are not only more environmentally responsible, but also socially just and economically viable. The future of food production will require continued innovation, collaboration, and a systems-based approach that integrates the ecological, economic, and social dimensions of sustainability. By designing agricultural systems that work in harmony with nature, we can ensure that future generations have access to nutritious, abundant, and sustainably produced food. Part 8. Sustainable Design in Manufacturing and Product Design. The impact of manufacturing on sustainability. Manufacturing processes have a profound impact on the environment. From resource extraction and energy consumption to pollution and waste generation, the traditional manufacturing sector is a significant contributor to environmental degradation. As the global demand for products increases, the challenge is to create manufacturing systems that minimize negative environmental impacts while still meeting consumer needs. Sustainable manufacturing aims to reduce the carbon footprint of production, minimize waste, and use resources more efficiently. By focusing on materials, energy usage, supply chains, and waste reduction, sustainable manufacturing processes can help mitigate environmental impacts and promote circularity. Principles of sustainable manufacturing. Sustainable manufacturing incorporates several key principles aimed at improving environmental, social, and economic performance. The core principles include resource efficiency. One of the primary goals of sustainable manufacturing is to use resources more efficiently. This includes reducing raw material usage, water consumption, and energy consumption throughout the production process. Techniques to improve resource efficiency include lean manufacturing, a system that focuses on minimizing waste in time, materials, and labor while maximizing value to the customer. Design for resource efficiency, developing products that require fewer resources to produce, such as using less material in production or selecting more sustainable raw materials. Energy optimization, reducing energy consumption during manufacturing by using energy-efficient machinery, systems, and practices, as well as adopting renewable energy sources where possible. Circular economy and closed-loop systems. In a traditional manufacturing model, products are often designed for obsolescence, and materials are discarded after use. The concept of a circular economy encourages manufacturers to design products and systems that facilitate the reuse, recycling, and regeneration of materials at the end of their life cycle. Product life extension, designing products that are durable and can be easily repaired or upgraded, thereby extending their lifespan. Recycling and upcycling, ensuring that materials from old products can be reused to create new products, reducing waste and the need for new raw materials. Closed-loop systems, designing manufacturing processes in a way that materials are returned to the production cycle rather than being discarded as waste. For example, using recycled materials in production or reusing waste from one part of the process in another. Sustainable materials and manufacturing processes, the materials used in manufacturing, have a significant impact on the environment. Sustainable manufacturing prioritizes the use of renewable, non-toxic, and recyclable materials. Sustainable sourcing, choosing raw materials that are responsibly sourced and have minimal environmental impact. This can include materials like bamboo, which is fast-growing and renewable, or recycled metals, which reduce the need for mining. Non-toxic chemicals and processes, eliminating harmful chemicals and substances from manufacturing processes, such as volatile organic compounds, VOCs in paints, or toxic solvents used in electronics production. Biodegradable and recyclable products, designing products that can decompose naturally or be easily recycled at the end of their life cycle. Waste minimization. Waste is a significant environmental issue in manufacturing. Sustainable manufacturing focuses on reducing waste throughout the production process and at the end of a product's life. Zero-waste manufacturing, aiming for a manufacturing process where all byproducts are reused, recycled, or composted, ensuring that no waste is sent to landfills. Material substitution, using alternative materials that generate less waste or have a lower environmental impact during production and disposal. Packaging reduction, minimizing the use of packaging materials or using sustainable packaging options, such as biodegradable or recycled materials. Energy and water conservation, manufacturing processes can consume large amounts of energy and water. Sustainable manufacturing practices focus on conserving both resources through various measures. Energy-efficient equipment, using machinery and technology that consume less energy, such as energy-efficient motors and LED lighting. On-site renewable energy generation, installing renewable energy systems like solar panels or wind turbines to power manufacturing facilities. Water-efficient processes, implementing water recycling systems, using less water in cooling processes or adopting closed-loop water systems to reduce water consumption. Sustainable product design. Sustainable product design is a crucial aspect of reducing the environmental impact of manufacturing. By incorporating sustainability into the design phase, products can be created with minimal environmental impact throughout their life cycle, from production to disposal. The key aspects of sustainable product design include design for longevity, creating products that are durable, easy to maintain, and repairable ensures that they will have a longer lifespan and less impact on the environment. This includes modular design, designing products with interchangeable parts that can be easily replaced or upgraded. Durable materials, using materials that are robust and have a long lifespan, reducing the need for frequent replacements. Repairability, designing products in such a way that they can be easily repaired, such as offering replaceable parts or providing clear repair instructions. Design for disassembly, products that are designed for easy disassembly can be more easily recycled or repurposed at the end of their life cycle. This reduces waste and ensures that valuable materials can be recovered and reused in new products. Easy to remove fasteners, using screws instead of glue or welding so that components can be easily separated. Modular components, designing products with separate, easily removable parts that can be individually recycled or repurposed. Clear labeling, marking parts and materials with information about how to recycle or dispose of them. Design for circularity, circular design focuses on creating products that can be reused, refurbished, or recycled, thereby minimizing waste and reducing the need for new raw materials. Recyclable materials, using materials that are easy to recycle, such as aluminum, steel, or certain plastics. Cradle-to-cradle design. Designing products so that their materials can be used indefinitely through recycling or upcycling, rather than following a cradle-to-grave model where materials are discarded after use. Minimalist design. Products with a minimalist design tend to use fewer resources in both manufacturing and packaging. By reducing excess material, unnecessary components, and packaging, manufacturers can create more sustainable products. Simplified packaging. Using less packaging or packaging made from sustainable materials like recycled paper or biodegradable plastics. Functional design. Prioritizing the core function of a product and eliminating unnecessary features that may add to the environmental impact. Ethical and social considerations. Sustainable product design also includes considering the social and ethical implications of a product's design and manufacture. This includes fair labor practices, ensuring that workers involved in the design and production processes are treated ethically, with fair wages and safe working conditions. Local sourcing. Sourcing materials and labor locally to reduce transportation-related emissions and support local economies. Transparency. Providing consumers with clear information about how products are made, including sourcing, manufacturing processes, and environmental impact. Case studies in sustainable manufacturing and product design. Patagonia, USA. Patagonia is a leader in sustainable product design and manufacturing. The company focuses on using recycled materials, such as recycled polyester and wool, in its clothing products. Additionally, Patagonia encourages consumers to repair, reuse, and recycle their products through initiatives like the Worn Wear program, which helps extend the lifespan of its garments. IKEA, Sweden. IKEA has made significant strides in sustainable manufacturing by committing to using renewable and recycled materials in its products. The company aims to produce all of its products using sustainable materials by 2030. IKEA has also focused on energy-efficient manufacturing and reducing its carbon footprint, as well as making its products easier to disassemble for recycling. Fairphone, Netherlands. Fairphone is a company dedicated to ethical manufacturing and sustainable product design in the electronics industry. Its smartphones are designed for longevity, repairability, and recyclability. Fairphone uses conflict-free minerals and ensures fair labor practices throughout its supply chain, focusing on reducing the negative social and environmental impacts of electronic waste. Tesla, USA. Tesla's electric vehicles are designed with sustainability in mind, focusing on energy efficiency and reducing the carbon footprint of transportation. The company has made substantial efforts to manufacture its vehicles with renewable energy and to minimize waste during the production process. Tesla's focus on sustainability extends to its gigafactories, which aim to be powered entirely by renewable energy. The future of sustainable manufacturing and product design. The future of sustainable manufacturing and product design will be shaped by continued technological innovation, regulatory pressures, and evolving consumer expectations. Key trends include advanced manufacturing technologies. Innovations such as 3D printing, artificial intelligence, AI, and robotics are transforming manufacturing processes. These technologies can reduce waste, improve precision, and enable on-demand production, leading to more efficient and sustainable manufacturing. Eco-design standards and regulations. Governments and regulatory bodies are increasingly setting stricter environmental standards for manufacturing and product design. This includes regulations on product recyclability, energy consumption, and emissions. These standards will drive further innovation in sustainable manufacturing practices. Consumer demand for sustainable products. As consumers become more environmentally conscious, the demand for sustainable products is expected to grow. Manufacturers will need to respond to this shift by incorporating sustainable design principles into their products and communicating the environmental benefits to consumers. Conclusion: a path toward sustainable manufacturing. Sustainable design in manufacturing and product development is essential for reducing the environmental impact of production and consumption. By adopting principles such as resource efficiency, circularity, energy conservation, and ethical sourcing, manufacturers can contribute to a more sustainable future. The integration of sustainability into product design not only reduces waste and emissions, but also meets the growing consumer demand for more environmentally friendly products. As we move forward, innovation in manufacturing technologies, better materials, and ethical practices will continue to shape the future of sustainable product design. By embracing these practices, industries can help create a more sustainable and resilient global economy. Part 9. Sustainable Design in Architecture and Urban Planning. Introduction: The importance of sustainable architecture. The built environment plays a crucial role in shaping the sustainability of our societies. Buildings and urban spaces account for a significant portion of global energy use, resource consumption, and waste generation. As cities continue to grow, creating sustainable designs for buildings, infrastructure, and urban areas is more important than ever. Sustainable architecture aims to create structures that minimize environmental impact, promote energy efficiency, and enhance the quality of life for inhabitants, while balancing economic and social needs. Sustainable urban planning, on the other hand, focuses on designing cities and neighborhoods that are both environmentally responsible and livable. By integrating green spaces, efficient public transport systems, sustainable infrastructure, and eco-friendly building designs, urban planning can reduce pollution, improve air and water quality, and make cities more resilient to the effects of climate change. In this part, we will explore the core principles of sustainable architecture and urban planning, along with innovative strategies and case studies that illustrate how these principles are being applied worldwide. Core Principles of Sustainable Architecture. Sustainable architecture focuses on building designs and construction techniques that reduce negative environmental impacts and improve the long-term efficiency and sustainability of buildings. The key principles of sustainable architecture include energy efficiency. One of the primary goals of sustainable architecture is to reduce energy consumption, particularly from non-renewable sources. Strategies to improve energy efficiency include passive design, designing buildings to take advantage of natural energy sources such as sunlight and wind to reduce the need for artificial heating, cooling, and lighting. This includes optimizing building orientation, window placement, and insulation. Energy-efficient systems, using energy-efficient appliances, lighting, heating, and cooling systems to minimize energy usage. For example, LED lighting, energy-efficient HVAC, heating, ventilation, and air conditioning systems, and high-efficiency water heaters. Renewable energy integration, incorporating renewable energy sources such as solar panels, wind turbines, or geothermal energy into building designs to offset energy needs and reduce dependence on fossil fuels. Resource conservation, sustainable architecture seeks to reduce the consumption of non-renewable resources and minimize waste during the construction and operation of buildings. This includes sustainable materials, using materials that are renewable, recycled, or sourced from sustainable practices. Examples include bamboo, reclaimed wood, recycled steel, and eco-friendly concrete alternatives. Water conservation, incorporating systems that minimize water use, such as low-flow fixtures, rainwater harvesting, and greywater recycling. Water-efficient landscapes, like xeriscaping, can also help reduce irrigation demands. Construction waste management, reducing, reusing, and recycling construction materials to minimize waste sent to landfills. Indoor environmental quality, sustainable buildings prioritize indoor air quality, lighting, acoustics, and thermal comfort to ensure the health and well-being of occupants. This includes non-toxic materials, using materials that do not release harmful chemicals into the indoor environment, such as low VOC paints, finishes, and adhesives. Natural ventilation and lighting, designing buildings to maximize natural light and airflow, reducing reliance on artificial lighting and mechanical ventilation. This improves air quality and reduces energy consumption. Thermal comfort, ensuring that buildings are well insulated and have efficient heating and cooling systems that maintain a comfortable indoor climate year-round. Adaptability and durability, sustainable buildings are designed to stand the test of time, both in terms of their structural integrity and their ability to adapt to changing needs. This includes flexible spaces, designing interiors that can be easily modified or repurposed for different uses, reducing the need for major renovations or demolitions in the future. Durable construction, using high-quality materials and construction techniques that ensure buildings have a long lifespan and require minimal maintenance. Resilience to climate change, sustainable architecture must also take into account the changing climate and its potential impact on the built environment. This includes climate-responsive design, designing buildings and urban areas that can withstand extreme weather events such as flooding, heat waves, and hurricanes. This may involve elevated foundations, stormwater management systems, and green roofs that reduce the urban heat island effect. Carbon sequestration, using materials and designs that absorb or offset carbon emissions, such as planting trees or using carbon-capturing building materials like bamboo. Sustainable urban planning, designing resilient and livable cities. Urban planning plays a critical role in shaping the sustainability of cities and regions. Sustainable urban planning focuses on creating cities that reduce environmental impact, improve social equity, and promote economic stability. The key components of sustainable urban planning include compact mixed-use development. Sustainable cities prioritize compact, mixed-use development that encourages walkability, reduces the need for cars, and promotes efficient land use. This includes transit-oriented development (TOD), designing neighborhoods around public transportation hubs to reduce car dependency and encourage the use of buses, subways, or trams. Pedestrian-friendly infrastructure, creating walkable streets with safe crossings, green spaces, and bike lanes that encourage walking and cycling as primary modes of transportation. Mixed-use zoning, integrating residential, commercial, and recreational spaces within neighborhoods, reducing the need for long commutes and fostering vibrant, self-sufficient communities. Green infrastructure. Green infrastructure uses natural systems to provide environmental, social, and economic benefits. It focuses on managing stormwater, improving air quality, and enhancing biodiversity within urban areas. Key elements of green infrastructure include green roofs and walls, installing vegetation on rooftops and building facades to improve insulation, reduce heat island effects, and enhance biodiversity. Urban forests and parks, creating green spaces within cities to provide recreational areas, reduce pollution, and improve mental well-being. Permeable surfaces, using permeable paving materials that allow rainwater to soak into the ground, reducing surface runoff and promoting groundwater recharge. Sustainable mobility, reducing the environmental impact of transportation, is a key component of sustainable urban planning. Strategies to promote sustainable mobility include public transportation systems, expanding and improving public transit networks to provide accessible and affordable transportation options for all residents. Electric vehicles (EVs), supporting the adoption of electric vehicles by installing EV charging infrastructure and promoting policies that encourage the use of EVs. Car sharing and bike sharing programs, encouraging shared transportation options that reduce the number of private vehicles on the road and promote more sustainable commuting options. Affordable and sustainable housing. Sustainable urban planning must ensure that cities are livable for all, including vulnerable populations. This includes affordable green housing, designing and building affordable homes that are energy efficient, resource conserving, and resilient to climate change. This can include the use of low-cost, sustainable materials and energy-efficient technologies. Community-based planning, involving local communities in the planning process to ensure that developments meet the needs of residents, promote social cohesion, and provide equitable access to resources. Affordable transit access, ensuring that public transportation is affordable and accessible to all members of the community, including low-income residents. Case studies in sustainable architecture and urban planning. The Bullitt Center, Seattle, USA. The Bullitt Center is one of the greenest commercial buildings in the world, designed to be energy positive. It features a solar array that generates more energy than the building consumes, a rainwater harvesting system, and an innovative composting toilet system. The building's design maximizes natural lighting, reduces water usage, and minimizes its carbon footprint. Vauban District, Freiburg, Germany. The Vauban District in Freiburg is a model of sustainable urban planning. The neighborhood is car-free, with a focus on sustainable transportation options, such as bicycles and public transit. The district incorporates green roofs, energy-efficient buildings, and a strong community focus on sustainability, making it an exemplary case of eco-friendly urban living. Masdar City, Abu Dhabi, UAE. Masdar City is an ambitious sustainable urban development project designed to be a zero-carbon, zero-waste city. Powered entirely by renewable energy, the city uses solar panels, wind turbines, and energy-efficient building technologies. It is also designed to be walkable, with a focus on sustainable transportation, such as electric driverless vehicles. The High Line, New York City, USA. The High Line is a former elevated rail line in New York City that has been transformed into a green space and public park. The project is an example of adaptive reuse, where an old industrial structure is repurposed to create a sustainable urban park that provides ecological benefits, improves air quality, and offers recreational space for residents. The future of sustainable architecture and urban planning. The future of sustainable architecture and urban planning will be shaped by emerging technologies, increased awareness of climate change, and growing demand for more livable and resilient cities. Key trends include smart cities. The rise of smart city technologies, including IoT, Internet of Things devices, big data, and artificial intelligence, is enabling cities to become more efficient, sustainable, and responsive. These technologies can optimize energy usage, improve traffic flow, and enhance public services, contributing to the creation of more sustainable urban environments. Net zero energy buildings. The push toward net zero energy buildings, which produce as much energy as they consume, will continue to drive innovation in architecture. This includes the integration of renewable energy sources, energy-efficient building materials, and advanced building technologies to reduce a building's energy demand to zero. Resilient infrastructure. As climate change leads to more frequent extreme weather events, cities will need to invest in resilient infrastructure that can withstand floods, heat waves, and other climate-related challenges. This includes flood-resistant building designs, heat-reflective materials, and robust transportation systems. Conclusion: building a sustainable future. Sustainable architecture and urban planning are essential to creating cities and buildings that meet the needs of present and future generations. By prioritizing energy efficiency, resource conservation, resilience, and social equity, we can design spaces that enhance the well-being of inhabitants while minimizing environmental impacts. Through innovative design and forward-thinking planning, we can build a sustainable future that balances ecological, social, and economic needs. Part 10. Sustainable Design in the Fashion and Textiles Industry. Introduction: the environmental impact of fashion. The fashion and textiles industry is one of the largest sectors in the global economy, but it is also one of the most resource-intensive and polluting industries. From the cultivation of raw materials, such as cotton, to the production of garments and their disposal, fashion has significant environmental and social impacts. As the demand for fast fashion increases, the environmental footprint of the industry continues to grow, with issues such as water pollution, textile waste, and carbon emissions reaching alarming levels. In response to these challenges, sustainable fashion is emerging as a movement aimed at reducing the negative impact of clothing production and consumption. Sustainable design in fashion focuses on using eco-friendly materials, adopting ethical production practices, and promoting a circular economy where products are reused, recycled, and upcycled. This part will explore the principles of sustainable fashion, the challenges faced by the industry, and the innovative solutions being implemented to address these issues. Core principles of sustainable fashion. Sustainable fashion involves various strategies and principles aimed at reducing the environmental, social, and economic impacts of clothing. The key principles of sustainable fashion include eco-friendly materials. The choice of materials is one of the most important factors in determining the environmental impact of a garment. Sustainable fashion promotes the use of natural, biodegradable, and low-impact materials that require fewer resources to produce. Key material choices include organic cotton. Grown without the use of synthetic pesticides or fertilizers, organic cotton is less harmful to the environment and promotes healthier ecosystems. Recycled materials. Using materials that have been previously used and processed, such as recycled polyester, reduces the need for virgin resources and helps to minimize waste. Hemp and bamboo. Both hemp and bamboo are fast-growing renewable resources that require fewer pesticides and less water compared to conventional crops like cotton. Tencel, lyocell, a biodegradable fabric made from sustainably sourced wood pulp. Tencel is produced using a closed-loop process that recycles water and solvents, making it one of the most eco-friendly textiles available. Ethical production practices. Ethical production is central to sustainable fashion, addressing issues such as fair wages, safe working conditions, and the avoidance of child or forced labor. Ethical fashion brands focus on ensuring that their garments are produced in factories that adhere to high labor standards. This includes fair trade certification. Brands that are fair trade certified ensure that workers in developing countries receive fair wages, work in safe conditions, and are treated with respect. Local and small-scale production. Producing clothing locally or in small-scale artisan settings can help reduce transportation emissions and support local economies. Transparent supply chains. Fashion brands that commit to transparency provide information about where and how their garments are made, ensuring that consumers can make informed purchasing decisions. Waste reduction and circular fashion. The concept of circular fashion focuses on extending the lifespan of clothing and minimizing textile waste. Instead of following the traditional take-make-dispose model, circular fashion encourages the recycling and reuse of garments at the end of their life cycle. Key strategies for waste reduction include upcycling, transforming old or discarded clothing into new high-quality items, thus reducing waste and minimizing the need for new materials. Clothing swaps and secondhand shopping, encouraging the reuse of clothing through resale swaps or thrift stores, helps extend the life of garments and reduces the need for new production. Garment repair and alteration. Offering services for repairing or altering clothing encourages consumers to keep their garments longer, reducing the demand for new items. Energy and water conservation. The fashion industry is a major consumer of water and energy, particularly during the production of textiles and garment manufacturing. Sustainable fashion seeks to reduce energy and water consumption by water-efficient textile production, implementing technologies and practices that minimize water use in dyeing, finishing, and fabric production. Energy-efficient factories, investing in renewable energy sources, such as solar or wind power, and adopting energy-efficient machinery in manufacturing plants to reduce carbon emissions. Durability and longevity. Sustainable fashion encourages the design and production of high-quality garments that are durable and long-lasting. This reduces the need for frequent replacement, lowering the overall environmental impact of fashion. Strategies to promote durability include timeless designs, creating clothing that is classic and versatile, so it can be worn for many years without going out of style. High-quality construction, using strong, durable fabrics and high-quality stitching to ensure that garments can withstand frequent use and laundering. Care instructions, educating consumers about how to care for their garments properly to extend their lifespan. This includes washing clothes in cold water, air drying, and avoiding excessive ironing. Sustainable fashion and the circular economy. The fashion industry is beginning to embrace the principles of the circular economy, which aims to keep materials in use for as long as possible and eliminate waste. Circular fashion focuses on creating closed-loop systems where garments are reused, repaired, and recycled instead of being discarded in landfills. Some of the key elements of circular fashion include clothing recycling programs. Several fashion brands are offering take-back programs where customers can return old clothing in exchange for discounts or other incentives. These garments are then recycled into new fabrics, reducing the need for virgin materials. Companies like Patagonia, H&M, and Levi's have implemented garment recycling programs that encourage consumers to recycle their clothing rather than throw it away. Product take-back and remanufacturing. In addition to recycling, some fashion brands are exploring remanufacturing, where old garments are disassembled, cleaned, and repurposed into new products. This helps to reduce the demand for new materials and lowers the overall environmental impact of production. An example of this is the closed-loop garment system, where a brand takes back its products and uses them to make new products, creating a circular life cycle for clothing. Material innovation and closed-loop fabrication. Innovators in the fashion industry are developing new materials that can be easily recycled or biodegraded, ensuring that they do not end up in landfills at the end of their life cycle. For example, companies are experimenting with biodegradable fabrics made from plant-based materials, such as algae or fungi, which can break down naturally without harming the environment. Challenges in sustainable fashion. While sustainable fashion is gaining momentum, there are several challenges the industry must overcome. Cost and affordability. Sustainable materials, ethical production practices, and waste reduction strategies can increase the cost of production. As a result, sustainable fashion items are often priced higher than fast fashion alternatives, making them less accessible to a wider audience. However, as demand for sustainable fashion grows, economies of scale may help lower these costs over time. Fast fashion consumer culture. Fast fashion, characterized by cheap, trendy clothing that is produced quickly and cheaply, has become the dominant model in the fashion industry. Changing consumer behavior and encouraging people to buy fewer, higher-quality items can be a difficult task. Raising awareness about the environmental and social impact of fast fashion is crucial to shifting consumer habits toward more sustainable choices. Supply chain complexity. The fashion supply chain is highly complex, with multiple stages of production and various materials sourced from different regions. Ensuring that every aspect of the supply chain adheres to sustainable practices can be challenging. Transparency and traceability in the supply chain are essential for ensuring that brands are truly committed to sustainability. Waste and overproduction. Despite efforts to reduce waste, overproduction remains a significant issue in the fashion industry. Brands often produce more garments than are needed, leading to excess inventory that ends up being discarded or incinerated. Addressing overproduction requires better forecasting, demand planning, and a shift towards slower, more deliberate production processes. Case studies in sustainable fashion. Patagonia, USA. Patagonia is a pioneer in sustainable fashion, focusing on environmental and social responsibility throughout its supply chain. The brand uses organic cotton, recycled materials, and fair labor practices in its production. Patagonia also encourages customers to buy less by promoting repair services and second-hand clothing through its Worn Wear program. Stella McCartney, UK. Stella McCartney is a luxury fashion brand that has been at the forefront of sustainable fashion. The brand uses sustainable materials, such as organic cotton, recycled polyester, and plant-based leather, in its collections. Stella McCartney also advocates for animal rights and avoids using any animal-derived materials, such as wool or silk. H&M Conscious Collection, Sweden. H&M has launched its Conscious Collection, which features garments made from sustainable materials such as organic cotton, recycled polyester, and tencel. The company has also implemented garment recycling initiatives, allowing customers to bring in old clothes for recycling in exchange for discounts. Levi's USA. Levi's has embraced sustainability by incorporating recycled materials into its denim products, using water-saving technologies in production, and reducing the environmental impact of its supply chain. The brand also offers a clothing repair program to extend the life of its garments. The future of sustainable fashion. The future of sustainable fashion holds promise, with the potential for significant environmental and social improvements. Key trends that will shape the industry include: material innovation. Advancements in material science will continue to drive the development of more sustainable textiles. New materials, such as biofabricated fabrics made from fungi or algae, and biodegradable textiles, will reduce the environmental impact of clothing. Increased consumer awareness. As more consumers become aware of the environmental and social impact of their clothing choices, the demand for sustainable fashion will likely increase. Brands will need to be transparent and responsible in their practices to meet this demand. Technology and sustainability. Innovations in technology, such as 3D printing and AI-driven design, will allow for more sustainable production methods, reducing waste and improving efficiency. Additionally, digital platforms that allow for virtual try-ons and fashion rentals may reduce the need for consumers to purchase new clothing. Conclusion: a more sustainable fashion future. Sustainable design in fashion offers a path forward for an industry that has long been associated with waste, pollution, and exploitation. By embracing eco-friendly materials, ethical production practices, waste reduction, and circularity, the fashion industry can reduce its negative environmental and social impacts. However, achieving a truly sustainable fashion system will require collaboration between brands, consumers, and policymakers, along with continued innovation and a shift in cultural attitudes toward consumption. Part 11. The Path Forward in Sustainable Design. Sustainable design is not just a trend, it is a necessary evolution of how we approach the creation of products, buildings, and systems that affect our world. As we've explored in this course, sustainable design spans numerous industries, from architecture to fashion to product design, and it is vital in addressing the pressing environmental, social, and economic challenges we face in the 21st century. The principles of sustainability, energy efficiency, resource conservation, waste reduction, and the promotion of social equity are becoming fundamental in every design decision we make. We have learned that sustainability is not about choosing one over the other, but about balancing ecological, economic, and social considerations to create solutions that last. From energy-efficient buildings that reduce carbon footprints to fashion that celebrates the circular economy, sustainable design represents the future of how we live, work, and interact with the world. By embracing sustainability, we not only address the critical issues of climate change, pollution, and waste, but also create better, healthier environments that contribute to the well-being of all living things. However, the path forward will not be without its challenges. Overcoming the inertia of traditional practices, combating fast fashion, scaling up sustainable technologies, and shifting consumer behavior all require time, investment, and collective action. While the road to a sustainable future can seem daunting, it is paved with opportunities for innovation, creativity, and collaboration. The role of designers, architects, engineers, business leaders, and consumers is pivotal in shaping this future. Sustainable design is a shared responsibility. As the global community increasingly recognizes the importance of protecting the planet for future generations, sustainable design will play an integral part in ensuring that we leave behind a legacy of resilience, equity, and harmony with nature. Ultimately, Sustainable design is not just about making changes in the products we consume or the buildings we inhabit. It is about reshaping our approach to how we interact with the planet, how we consume resources, and how we value the relationships between people, places, and products. It is about rethinking what is possible, embracing new paradigms, and designing with the future in mind. By continually striving for sustainability in every aspect of design, we take one step closer to creating a world that not only meets our needs, but also nourishes the planet and its inhabitants. Through education, innovation, and action, the dream of a sustainable, thriving future is within our reach. This course has provided an overview of sustainable design principles and practices across various industries, but it is by no means the end of the journey. As we continue to explore and innovate, let us all contribute to a world where design fosters positive change, where sustainability is no longer the exception but the rule. The future is sustainable, and the time to act is now.